So let's talk about networking basics now, and let's try to understand that how the networking works and what kind of options we can have in networking. We discussed about OSI model. We discussed about the IP addressing last time, and now we will expand that knowledge and see how networking works. Let's first talk about networking in physical world. So networking in physical world, if we have to connect these services, what I would have physical servers. And these physical servers have to talk to different servers altogether. And for that, what we would be needing some type of connectivity in them. And for that, we would need network interface card. You call it LAN card or Ethernet card or network interface card. That is a mechanism by which your signals are captured and transferred over the wire, or it could be over the air, which could be Wi-Fi. So physical servers would require some type of network interfaces to communicate to, and these network interfaces have to be connected to something called a network switch. And through this network switch, you are able to communicate and attach all these devices together. And one network switch, when you have, it would have a limit that it can have only 8 port or 16 port or 32 or in multiple of 2. So that many ports exist on a switch and that many devices can be connected. So obviously you would hit a limit that how many more devices you want to connect. One switch may not be sufficient enough. So probably what we would have a switch added to another switch, right? And we expanded our network. Now, if one switch could connect 64 hosts, another switch with 64, so total I could have 128 hosts created, right? So we are adding them one by one and we are creating a network. I'm just giving a basic example here. But the problem with this type of big network would be, think like you are in a big room in which there are hundreds of people and they are all chatting, they are all talking to each other. That would mean there would be a lot of noise happening, and which may not be good for some of you. So probably what we may want to divide that particular floor on different rooms. So maybe this is a meeting room, and maybe this side is a training room here, maybe this side is something else, so that we could go ahead and do that. So what we are doing here, we are creating logical partitions within it. Maybe we could put a door here and call it, this is, let's say, your development block. Maybe this there is a door, and then we can say it is a QA block. This door here, it is your office admin or HR block. So we created a logical partition on the floor. Similarly, what we would be doing, we would be creating logical partition on this network which we have created, and those are called VLAN in physical world, called virtual LAN. So virtual LAN are your logical isolation on a physical network. Like I have a VLAN here called, let's say, public, all my public facing resources put together there, or my VLAN private, all my private resources, or I have a VLAN called HR, another VLAN called dev, another VLAN called QA, and these are all logical isolations which I could create for my application. So I hope this thing is clear. What is a VLAN? Now, if these VLANs have to talk, they would require routing devices, right? So if you are into one block and you have to go to another block, you would need a corridor from which you could go and come at the other end, and same will be followed by other people also. So you need corridors to communicate across different networks, and that corridors are provided by the router. Router tells you where to go. It is like a map. If you want to go from point A to point B, you go into your Google Maps, search for destination, and it shows you route, and you can be then selecting what you are trying to go, where you are trying to go, and how you are going to. How is a switch different from a router? Good question. Let me explain that. Switch works on something called layer 2. This works on something called layer 3. Let me give an example rather than just talking technical, right? So if you are trying to talk to, let's say you are into a one switch here, and you are computer 1 here and computer 2 here. Now, if you both want to communicate, let's say you're living into the same house, what you would need, you have to just shout out and you would be able to hear to that person, or they would be able to hear you because you are into the same house, right? You do not call your son or daughter or your spouse living within the same house. You just go to them and talk. That was is happening is a layer 2 communication. You do not need a mobile device for that. So in layer 2, the addressing mechanism is called MAC addresses, and through MAC addresses, it just says, hey, I am trying to talk to someone with this detail, and then A respond, this is me, tell me what you want. So that is my layer 2. So when the packet is created, when this your let me clear this out. So when your packet is being created, there will be MAC address added and there will be IP address added on the packet. So this is my data. On that data there will be a MAC address, like who sent the packet, the physical device, and there will be IP address added on that, right? Like you are making a or sending a packet locally to someone. So in that case, a local courier company can forward that, and they won't need uh, the the what you call they won't be needing the country detail for that package, because this is a local packet. They know this is going to be in the same country. But if the packet has to travel to outside another country, what would be required in that case, that you would have to add country information there, and that would be a different route a packet would be following. That is your router. So router add IP addresses for your packet so that it can go beyond just network switch only have capability to forward packet on a local network, but router can forward your packet onto remote network also. And the way they work, little more technical, and I would be happy to have it offline if needed. So this one is a layer 3 device. It works based on IP address in the packet, and network switches are your layer 2 device, which works based on the MAC addresses of this physical LAN card which we have created, right? Think of it that you and I call to each other using the mobile numbers we have, right? But when this mobile number are making call to each other, what is actually happening? The service provider registers the IMEI number of my mobile who is making the call, and that IMEI number is making call to another IMEI number of another person. Right. This is the service provider or your mobile provider's view. This is your view that you are making a call. So this is happening behind the scene is your switch who is talking in terms of MAC addresses, the physical addresses. What is happening here is your router who is talking in terms of IP addresses, right? So IP addresses you assign, IMEI number in your mobile assigned by the manufacturer. Same way, MAC addresses in your network card is assigned by the card manufacturer, Intel, AMD, whoever has that networking card produced or manufactured. They would hard code a stamp on it. It is like a fingerprint which you can't change. Name, I could change my name or I could keep whatever name I like. That is your IP address. So router decide on IP, MAC is used by network switches. Maybe a little longer discussion, but yeah, hopefully you have a better idea now. Okay. All right. So once we have sorted this thing, probably we may also want to go and talk to internet. You are welcome, Parna. So we would go to internet and we want to communicate there. Switch intra-network MAC addresses, router inter-network IP address. Good summary there, Vidhata. Thank you. Now, when I'm trying to talk to internet, probably I would also put some firewalls, because internet is not considered the safest network. So I would have a firewall added, and that firewall probably would have an internet router who would connect me to the outside world, and that's how my communication would be established. This is a very basic network you have. Now, if I'm talking about a home network, probably functionality of these three devices, router, firewall, and internet router, would be in your Wi-Fi device, which is given to you by your service provider. So that is a single device playing all the role. But when we are talking about corporate network, probably these will be different devices who are doing different tasks, but every device has its own work to do. This is how a small network looks into physical world. Let's see how the same works into AWS world. Let's talk about that. So now I am trying to explain you the concept of things in AWS. In AWS, we do not give you access to directly of a physical server. You get access to EC2 machines. So you have your EC2 machine, which is equivalent to your servers into the cloud. Then these network interfaces are still required, but we have a different way of giving you the network interfaces. This is called ENI, which stands for Elastic Network Interface. So this elastic network interface would be created, and once this ENI is ready, you should be able to have your traffic sent out. We do not have a concept of VLANs in AWS cloud, but we are utilizing here something called subnet. They are equivalent, they are similar, they give you the isolation you are looking for, but you do not get access to a network switch directly. We had to implement it through something called a subnet, and we will discuss them in detail, don't worry. Instead of calling a router, we call that mechanism of routing called routing table. So routing table will decide how your packet will be transferred from one network to another network and what kind of data would be going through that. That will all happen through your routing table, right? Firewalls, yes, we have firewall to for protection, and they are implemented by security group and network ACL, which stand for access control list. Now, a disclaimer here. For explanation, I have said that this is a firewall, but in we will discuss this in our next sections that the security group and network ACL are not implemented at this layer. Right now in picture what you are seeing that my firewall in physical world is implemented on the perimeter layer when we are meeting the external network. But in cloud, we go and provide better security. And for that, we use security group and network ACL. We will have a dedicated discussion probably next week on these things and we'll see how it actually works. Right. For routing, yes, we use routers, which is internet router, which are called IGW, which is referred as internet gateway. And through this, you are able to communicate. So as you could see, there is not lot of a difference between a physical world and a virtual world or AWS world. But now I am going to introduce a component which is very unique in AWS. I hope everyone is following along here. The next component I am introducing here is called a VPC, Virtual Private Cloud. So what AWS is doing that they create this networking here and they give you a private space to run your networking. We don't want that if you create something and it creates problem with others or others create something which creates problem for you, it is not a good design. So you get a isolated architecture or isolated place to run your networking, and that is called a VPC, which stand for virtual private cloud. So VPC is your own networking space in which you create your servers. When you host your routing table, you create firewall solution, you create internet gateway. So all of this will be created inside a Amazon VPC. And now I would explain more on what VPC is and how it is implemented. Okay. I hope everyone is following along and you would be able to understand it. VPC is a SDN. I would defer there. SDN, which they are mentioning, SDN is your software defined network. I would say this is a combination of both the things, right? Why things are little differently implemented in AWS? Let me give an example. When AWS started building applications and they wanted to have a network which could scale to thousands of customers, which could have petabyte of data being transferred, and that time AWS started checking different vendors for the equipment they manufacture. Right. So they had to check a lot of vendors. All these vendor could not give the scale AWS was looking for. So what AWS had to do, AWS had to build their own networking from ground up. So probably the hardware we use for running this, probably the software we use for it, it is all being indigenously created by AWS for very specific use cases. It is not a commercial hardware like a Cisco or Juniper network. We have to build our own hardware and software because none of the vendor could give us the scale and the security we were looking for. So it is a form of SDN, which is called software delivered network, but it is also having its own hardware component behind the scene. Right. So hopefully this thing is clear. Let's focus on now Amazon VPC. What is a VPC and why we create it? Why we create it? First reason, we need isolation. So I want to keep my workload isolated. So that's why I would be creating my VPC. Whatever I do within this box won't go outside unless I add those components. Right. So you are living in a house. Consider initially when you designed the house, there was no door. So you are living inside, and if you have to go outside, you would be then adding doors here, and we will discuss different type of door you could add. But unless you have a door, you are keeping everything inside a VPC. Right? VPC is a regional entity, and in every region, we give you something called a default VPC. So a default VPC already exists for every region. Why we give that? So that if you are not coming from networking, you are a developer and you just want to deploy a EC2, you should not worry about all the stuff. You can use default VPC if you want. But most of the time, you would be using VPC created by own use cases. So first thing you would be creating to host application probably will be a VPC. Right now, if I am having a region here, a region is made up of availability zones, right? We already saw that. And for simplicity, I am not adding all the availability zones here, but I am just adding some of them here. See this. So what I have here, I have two availability zone. So when my VPC is created, that VPC would spread across multiple availability zones as we see here. So this would be spread across multiple availability zone. When I create a VPC, I just have to provide some very basic information and I would be good to get started. I do not need to have lot of setting configured. I could go ahead with the very basic setting and later I could then customize it as per my own requirement. So give me a minute. I would go ahead and deploy a VPC. Somehow my keyboard is not working as expected. My, sorry, here I'm coming up. I'm trying to type. Come on. aws.amazon.com. Now it works. So we will go there and we will first see the default VPC and we'll create our own VPC. And we will build things step by step. We won't be creating everything in one shot, though it is possible, but we will build things one by one. Subnet, then route table, and then association, then net gateway. That's what we are going to build here. So I'm signing into console and VPC is a regional entity to have to select which region I'm interested in. Let's say I want to see things into Oregon. So that's fine. And here I would search for the service, which is VPC, and read this instruction which says isolated cloud resources. So yes, we would be creating resources in an isolated manner. Let's go ahead and see that. A default VPC exists in all region unless you have deleted it. How to identify that? It would have a name, oh, sorry, it would have a tag which will tell that it is a default VPC, right? So there you see there are two VPCs for me here. VPCs US West 2, two VPCs on that. And here is this VPC, see this one. If you keep on scrolling here, it will tell you that is this a default VPC or not. So the bottom one is a default VPC which is created by AWS for me. I have not asked, but it will automatically be there in my account. So this is the VPC which I get by default. And I have one more clue here. This will have a IP address in the range 170 to 31. So in every region you go, you would find a IP address range of 170 to 31 for your default VPC. Right now, my interest is to create a VPC. Let me go ahead and create a VPC here. What I have to specify that I have to say what I am looking for. Am I looking to create VPC only or more? Maybe I am just creating VPC. Let me call it BESA VPC 01. Done. I have to provide a IP address range. This is a big umbrella IP address range, and from that, smaller IP addresses range will be used for your for your subnet. I am trying to keep here is a 10.0.0.0/16 as an IP address range. Right now, question to you. Probably some of you know the answer. Let me know. Let me show you the VPC again, and I'll ask you this question whether it is valid or not. So I'm going back to VPC console. I will show you what exists already. And we will then come back to the creation screen again. Give it a few seconds, let it render. Probably I should have selected Ireland as a region. It would be much faster to render, or London. So now I am here into VPCs, and if I go and further check, probably I already have a VPC, which is my VPC02, and it is using the same IP address range 10.0.0/16. So my question is, this VPC already exists in Oregon, and I am now trying to create same IP address range VPC in Oregon. Will I be allowed or will I be denied from creating it? What do you think would be happening in this case? What do you think? Would I be allowed to create this VPC or will I be getting an error? Conflict, it is allowed, it is a private range which can be used, denied, conflict. Let me do that, right? Better to see this thing in happening. Create VPC. Done. I provided the IP address range and I did not get any error. Remember the statement I made. VPCs are isolated resources. So it is still okay to have the same IP address range for VPC, but it is not very practical because now I have created an architecture where these two VPC would never be peering with each other because they are running into the same IP address range. So technically it is allowed, but we should avoid it because it would have connectivity issues if we plan to expand our network. But technically, yes, you could do. What could be use cases for this? Sometimes customers say that, hey, I want the exact same IP addresses for my production system. And when I'm testing, I also need the same exact set of IP addresses. So that's why you may be allowed to create it, but not a good thing if you are creating issue, if you are planning to peer these VPC, but I have created a VPC, right? So I'll focus on this base of VPC. Now there was a question that what IP address range you would be using, and let me read the question again. It was an interesting question. How do you know how to choose an address range? Good question there. Right. Now, what do we mean by that? We have to ensure or we have to think that what my network requirements are. For that, we have to go a little bit on the networking. Let's talk about something called private IP address ranges. So what private IP address ranges are? These are something which I can use internally, and these are non-routable IP addresses. So in IP address which we talked from 000 to 255.255, some of the IP addresses are kept for internal purposes, and that is displayed here. See this one. So if any IP address is in the range of 10.00 up to 10.2555, that is a class A private IP. This one is a class B private IP 172.16 something and 192 something. So from the whole range, some sections are kept for private communication. So you would be deciding on which range you want to use. You could use any of them, right? So depending on what range you want to use, you could select any of the classes, but only on this. If I am trying to create a VPC with the IP address range, which is not private, I may have an issue. Let's go ahead and try that. So I say I want to create a VPC. Let's call it a test VPC and see this. Let's say I put here that 1.1.0.0/16. That is the IP address range I am trying to put. See, done. Why you think so happen? Still happening, but we are not allowed to then use this as a public mechanism. Technically, internally, whatever IP address I want to do, I can, but this is not something which will work for internet routing because this is not having a valid private IP address range. Connectivity would be an issue in this VPC. Technically, you can create it because it is isolated as of now, but it would have problem when I create further networking component on that, right? So hopefully this thing is clear. Now, I would be selecting the range of the IP address depending on how many nodes I want to keep or how many subnets I want to keep there. So let's go to a simple setting CIDR.xyz. Here you would know what IP address to use. So you have to design that what does this 16 means. That's what I am now talking here. Uh, we will discuss that. So what I did here, I said 10.00 and that said 16, right? We discussed this last time little bit. So 16 here says I want to keep first 16 bits of this 32-bit for my network and remaining 16 bits I want to keep for host naming. Or if I have put it like this /8, that means I would be keeping first 8 bits for my network address and remaining 3 bits will be for my host addresses. So if I am having slash 8, see this, I would have these many IP addresses for my host, because now I have these total 30 to 24 bits available for me to provide IP addresses to my host. So that will be giving me a better large space for my application, right? Check my last video. I explained through a building example, like if you are using a building and naming system there, how you would number the building. So that will give you more idea. Now, instead of that, if I have created it as slash 24, which means I have less number of bits for host, and now I would have only 256 hosts available. So depending on my use case, I would be selecting the IP address range, which gives me sufficient IPs so that I could distribute to my machine. So if I plan to have only below 200 hosts in my network, this is fine. But if I feel I would be needing more hosts, then I should use a different IP address altogether. Right. So that is the way how I would be creating a VPC and would be selecting a IP address range associated with it. So once I create a VPC, this is whole network created for me. And once this is ready, I would then start hosting or creating subnets inside. Subnet is a logical isolation within it, like a VLAN. So VPC spans across multiple availability zone and it has a bigger IP address range. So let's say this, sorry, give me a minute. This was the IP address range we have selected 10.0.0.0/16. And now I am carving smaller pieces of that like a pizza slice, and that pizza slice is my subnet, right? So I have one subnet here which I am calling 10.0.1.0/24. So from these, this is my network address, and in this bits I am playing, and I say 1.0/24, 2.0/24. So these are the portion of the bigger chunk which I would be associating with my subnet, and I can create multiple subnet if the need be. Like I can create a public subnet called 10.0.1.0.24. Subnet exists within an availability zone. So let me go ahead to a VPC and try to create something called a subnet here, right? I hope everyone is following along and understanding why we are creating a VPC and how it is being created. So why is more important if you are a solution architect, not just the what. What is more important for people who are in operations, who are doing maintenance, who are doing implementation, so they would know how to do it and what to do it. But why would be more important for you as solution architect? So let me create a subnet here. I have to select a VPC. So this is my BESA VPC 01. I would be giving it a name. Now name is just for identification purpose to make your life much easier. So I would be using here some name as a friendly name so that we would have a better idea on what we are trying to achieve here. So I would call it public, sorry, public AZA. AZA stands for here for availability zone A, right? And I would be putting it intentionally into US West 2A, which is my availability zone 1A, and I would be putting some IP address range here. Let's go ahead. Come on. Somehow my keyboard is not working as expected today. I think some key got pressed somewhere. 10.0.0 slash sorry 1.0/24. So that is the first IP address I have selected, range I have selected, and I am given it a name public AZA, and I would create a subnet, right? One subnet ready. Public is just a name. Right now, it is not actually having any public resources. We'll discuss them in a minute. So one subnet ready. If I want, I could go ahead and create another subnet. I have to select which VPC I want. And in that VPC, I would again give it a name. Let's say I call it private and call it AZA. Right, so that is another subnet, and this I am creating again into 2A, and probably for this I want to use 10.0.11.0/24 as my IP address range, and I would be creating subnets like this. So subnet is a logical isolation which I am creating, and through these subnets I am able to add resources on that. So if I'm now looking for searching only for the VPC of my choice, these are the two subnet which I have just created in public AZA and private AZA. right? And you can follow this and create subnet across availability zones like this: 10 11 0 here, 20 12 0 here. And now once these subnets are ready, think of subnet like a wire, and on this wire you can now keep on adding your resources. So once your wires are connected, once your network has been laid out, now you would start adding resources here. Like you would have a resource like machine here A, and then you would have another instance here called B, C, D, and E, F, and G, H. So these instances can be now hosted on in a VPC. Instance are running within a VPC, but from connectivity perspective, they connect to a subnet, and a subnet scope is a availability zone, nothing beyond it. In a real world, do companies use default VPC, create their own, and whatever by delete default VPC? Anuj, it depends, I would say. If I am using lot of serverless architectures, probably I do not need VPC at all. You get the point? So there's no general answer to the question that do they use. It depends on the company to company. If I am the person, I would probably avoid it. Why? Let me give an example. What is happening? The default VPC, let's say this is in North Virginia and this is in Ireland. In all the places, my default VPC IP address is same: 172.31.xx, 172.31.xx, which means in future, if I had to pair these two, it won't be possible. And that's why I don't see a point in using default VPC. And maybe this VPC is created with /16, which I do not need, and that's why I may want to use a different IP address scheme. But if you want, nobody is stopping you. But I do not see this being followed in a regular practice because of one concern which I just shared. And second is that it may have /16, which you may not be looking for, or which may be small or large enough for your workload. So it depends on what you want to achieve from it. Right. Good. So once my machines are ready, we can then start communicating across them. Right. We will talk about that in some time. But I want to ask services which requires VPC. Anyone? What services in AWS would require a VPC? They won't exist without a VPC. Anyone? What are the some of the services we are aware which requires a VPC to function? EC2 RDS, exactly. So Amazon EC2 is one of the service. Then Amazon RDS is one of them. Relational database services. Yes. What else? Not probably everyone knows, but EC2, before VPC came, there are something called classic EC2. They can exist outside of VPC also. So that is little, it means it is not no more available, but you may find some customer running their workload from very long old time, which may even run outside of VPC because VPC came later. Initially, it was Amazon EC2. Right. So VPC came later, but yes, I would agree. Amazon EC2 RDS, we would use that. Then EMR, somebody mentioned Elastic Map Reduce. Yes, this would be running within a VPC. When you are deploying a load balancer, that would be again running within a VPC. Lambda, I would call Lambda as an amphibious animal because this could run within a VPC or it could run outside of VPC also. So that would be a different story altogether. Right. So Lambda can exist within a VPC and it can work outside of VPC also. So that is possible. Right. ELB, yes. Databases, yes. Not every database, Manish. Like if you have sorry, Manisha, I guess so Manisha, not every database, it could be a database like DynamoDB, it doesn't require a VPC, it works outside of that. So not everything. Direct connect, yes, direct connect would allow you to communicate, so you could utilize it for your communication channel, so that would be required. VPC endpoint, yes, it would require that VPC. VPN connection would require a VPC. So yes, these are some of the services which would require VPCs to function. But as you could see, this list is small. AWS has 200 plus services, and maybe around 20 can be running within a VPC. Most of them run outside of VPC. So we would talk about how to expand our network and how to add those services and how all these components will work together. So to summarize, we are nearing to the point of the timeline. So we talked about what is a VPC, why we need it, and what are the basic component to create a VPC. We would expand on this. Next topic, we would add more component here. We would create communication channel between them, and we'll see how all these things will be working together, right? So we would expand on that, and you would have access to this slide, and I would also be adding the service summary card of VPC. So you should have no problem in reading a little bit more, but we will expand more of this into the next chapter. So you would be having this VPC slide also, right? So I hope everyone is following along. If there is a feedback, anything we can do differently, anything which is making your life easier or it makes your learning easier, let us know. We would be happy to add those things for this. All right. Mostly global. Little depends, Babita, I would say, because we have services here like your global accelerator, and then global accelerator can work with VPC, though it is a global service, but it can work with VPC. So I would say yes, partially what you are saying is right, but exceptions always exist in AWS. There are services which has more beyond a VPC, or they operate within a VPC also. So I hope everyone has followed along. Now, uh, I guess everyone is following along, and if you have any suggestions, any questions, let us know. I would add Prasad now, and Prasad would now walk us through some of the components related to uh, Amazon S3 implementation, that how S3 can be used for practical things.